Okay, I'm going to try to hit some important things in section 1.3 to wrap it up with you all, and I just thought it'd be worthwhile for us to go back and try one more of these on our calculator to approximate the relative minimum and or relative maximum of f of x equals negative x to the third plus x to the nearest hundredths. So let's go to y equals, and let's plug in our function. And let's hit graph. Right now I'm starting out with my window in the standard window, the negative 10, 10, 1, negative 10, 10, 1. You can always make it go to the standard window immediately if you hit zoom 6 for standard. And I'm hitting graph. And my calculator is a little crunched up, and I can't exactly tell what's happening there. So I'd like to zoom in a little bit. So I'm just going to hit zoom in, choice 2, and hit enter. And then I get a much better picture of what's happening. So I can tell that I have a relative min here and a relative max here. I'm looking for hills and valleys. So we would have the and choice there, a relative min and a relative max. So first let's go to second calc, and let's calculate that minimum. Oops. All right, and it's prompting us left bound, so make sure you're arrowing over. Right over here to the left of this minimum point. That looks like the lowest point to me. You want to be to the left of it when you hit enter. And then it asks you for the right bound. And I want you to go over to the right of that minimum point and hit enter. And then the guess, I want you to try to get right on that minimum point. And then for me, it says x is negative point. We're going to round to the nearest hundredths place. I get negative 0.58, and I get y to be negative 0.38. Okay, and now we're going to calculate the max. So second calc, maximum. Again, let me erase these. This is our maximum. That looks like the maximum point right there. So when it wants me to be left bound, I need to be to the left of that point. And then a right bound, I need to be to the right side of that point. And then for the gas, try to get right on it. Right as close as you think you can be. And then it told me the max was positive 0.58. And it told me the y was 0.38. Oh, I don't know why I don't have my y value there for that minimum. Let me do that one more time. Minimum. Left. Right. Guess. Negative 0.38. So it's just strange that those are both the same, like except completely opposite. But is it really strange? Is this possibly an odd function where the x's and the y's would be completely opposite on the points? And if you were to reflect this piece right here over the x, well, we could reflect the whole thing. Yeah, let's just do that part. And then if you took this part and you reflected it over the y, ooh, look at there what we got. And if we were to do it with the whole part, if you reflect all of this over the x, then it's going to look like this. And then if you reflect all of this over the y, it's going to be that. So it is symmetry with the origin. So it's not really that strange after all. Okay, now we're going to talk about even and odd functions. 3 ways. So the first way we're going to talk about is we're going to say even, odd, or neither. And I'll give you f of x equals x minus 5 to the third plus x. We want to find out if it's either, odd, or neither. The test is always to do f of negative x. This is the algebraic way. In the homework they ask, is it algebraic, or to find it algebraic graphically, numerically. This is algebraic. So what you do is you put the negative x in the function. And then if anything can be simplified, you simplify things. And then you compare all of the signs with all of the new signs. Are they all exactly the same? No. Or if you just want to look, is this function exactly like the other one? No. So it's definitely not even. But is it odd? Are all the signs exactly opposite? No, because these are the same. These are opposite. These are opposite. But this one here in the middle is the same. So it's not odd either, so it's neither. Now, if we wanted to look at it graphically, we plug it into the calculator. And we look for symmetry. So let's plug this into our calculator. Parenthesis x minus 5. Close parenthesis to the third, arrow out of that, plus x. I'm still zoomed in. I don't know if that's going to work for me. Nope. I need to do zoom standard to get my normal screen. And my calculator is locked up. So this is what my graph looks like, and like we were talking about earlier, I'd like to know what's going on up here. So I might just do window, and this is my y, right? I'd like to know what's going on as y gets bigger. So I want to change my y maximum. So arrow on down till you see y max. And let's put like 30 in, and let's see what we see now. And I'll show you what I see now. So I feel confident now that I'm seeing the only relative max or min that there is. But I would sort of like to zoom in a little bit to see those dips and curves with a little more detail. So I traced over to get sort of around where the dips and curves were happening, and then I'm going to hit zoom in. And that's what I see. So I'm not sure if we have, I'm thinking mins and maxes, but I'm supposed to be talking about even and odd. I can actually go back to this screen right here. I apologize. I'm supposed to be talking about even and odd. I definitely don't have symmetry with the y. I fold on the y. There's nothing over here for that to match up with. So it's not even. Let's check symmetry with the x. If you take this piece, this is up in this quadrant, and you flip it over, then you would get that. And then when you flip it over the y, you'd get that. And that is definitely not going to match up with the bottom half of it. So it doesn't have symmetry with the origin either. This is neither, which agrees with what we found algebraically. Now numerically says to use the table. So we've got a function in the calculator already. So we'll just go to second table and we'll find a point. Let's see. I'm going to use 1. So I've got the point 1, negative 63. Well, in class today, we took notes on the graph, and we said it was even if I didn't quite write this up there. If xy is my point, it's even if the point negative xy is on my table. So it's even if I can find the point. So I want to change x's sign, but y stays exactly the same. And when I check out what negative 1's value is, it is not negative 63. So that means it's neither. So that means it's not even. And since it was so far off, it was negative, 217. So it's not odd either. Well, let me write down that rule for you right here. Numerically, it's even if every xy point becomes negative xy. So that means if you have 3, 4, then on your table, you also want to find negative 3, 4. If you have the point negative 6, negative 8, then on your table, x changes signs, y stays the same. And if that happens, then it's even. If it's odd, for every xy on your table, you would find negative x, negative y. So if 3, 2 is on your table, negative 3, negative 2 would be, if it's odd. If negative 8, 5 is on the table, then positive 8, negative 5 is. See, we changed both of their signs. That's the way odd works. Okay, let's do another. Start to finish. Let's do even, odd, or neither. And let's do it algebraically. Testing negative x. So you plug in a negative x, and then you simplify it. And then you compare this new function with the old function, because we wrote down if f of negative x was equal to f of x, that meant it was even, like cosine. But if f of negative x was equal to exactly the opposite of f of x, then that was odd. So when you compare these, they are not exactly the same. They are not exactly opposite, so it's neither. Graphically, I'm not going to pull it up on my calculator. I'm going to plot it like we talked about today. Plot your y-intercept. Down 3, right 1. Down 3, right 1. We're looking at that line. That line is not going to have symmetry with the y. If you flipped it over, it would look like this. There's nothing over there for it to match with. Right? It does not line up on itself. Doesn't have symmetry with the y. And symmetry with the x says, take this, flip it over the x. Now take that and flip it over the y. Did that line up on this other piece? No, not at all. So it's neither. Numerically, I need a point on this graph. Well, I just found this point right here. Let's see, it was 2, -1, I think. So if it's even, using these rules that we just wrote down, then the point -2, -1 should be on my graph. But it's not. So it's not even. If it's odd, then the point -2, +1 should be up. Whoops, that was not -1. -2, -1's right there. -2, +1, that's also not on my line. So it's actually neither. All of these should agree with each other because we're finding the same answer, just 3 different ways. Hopefully that helps. Email me if you have a question.